Hi there, welcome back to another C programming language tutorial lesson on IT Genius Cyber. And I remember last time we tried to look at operators, the likes of arithmetic operators, the likes to do with addition operator, subtraction operator, and the multiplication, as well as the division. So I'm really sure that all of you can now really write a system that is having arguments of addition, subtraction, multiplication, and division as well. Yeah, but today we're going to talk about more of some other operators, and we shall look at dealing with if statements, and we shall also look at switch statements. Sorry. Yeah, we shall look at switch statements. Yeah. Meanwhile, most people prefer using any of these. You can actually go on with using an if statement if you want, or switch statements. But meanwhile, they all do the same function actually, but it depends on your preference actually. So last time we covered a little bit on arithmetic operators, and today we're going to look at as well assignment operators, and we are going to look at comparison operators, as well as logic operators. Okay. So we're gonna cover up our operators, then after that we shall go to if statements, then after if statements we shall have switch statements as well. Okay, but under operators we try to look at arithmetic operators, and those are operators to do with the subtraction, the addition, the multiplication, and division. Yeah, and division. I remember I missed out giving you some other arithmetic operators, the likes to do with the increment operators and the decrement. Sorry, the decrement operators. These are increments. Sorry. Oops. And these are decrements. Yeah, decrement operators and increment operators. Then I didn't also talk about the likes to do with a modulus operator. So I'm going to also talk about the modulus operator, decrements, and increments. But my preference was talking about increments and decrements. I actually wanted to bring them when we get to the likes of the loops, that is to do with a for loop and do while loop. Yeah, mostly people use them there, as well as you can actually use them elsewhere, but I'll give more detailed explanation when we really get to that, and that is in our next tutorial. But for modulus, I'm going to give you some little few examples about modulus. Yeah, and what we understand about modulus, that is a remainder after dividing a number or a value with any variable or with any integer of your choice. Actually, it can be an integer, it can be a float value, any value you want. So that number that remains is what we call the modulus. And then after here, we before I get to that, let me try to explain about modulus. Then after modulus, we shall go with assignment operators as well later on. Let me try to open up here and try to give you a visible example. Okay, so I'll create a blank file and I'll try to save my file. I'll call this lesson 5. Then I'll call my program operators .cpp. Okay. So we hash include so bring out main function. Okay, then I'll put my return value here. Okay, so like that. So let me try to give you an example. Let's say I'm having a variable, so I'm going to declare a variable, say int x, and I'll say int y, so an integer of x, and I'll assign my variable for x as 5, and I'll assign my default value for y as 3, 2. Let me just give it 2. Okay. So I'm going to try to explain more about modulus, what we mean by modulus, because I said modulus means the remainder value after dividing a number. Okay, so I'll print out if. I'll give it a new line and a new tab. Then I'll say call for my integer value for the modulus. Let's say I'm saying modulus of x modulus y, then I'll say like that. So this should give me the remainder after dividing x. So when you divide x by y, what is the remainder? It's that value we need, or it's that value it should actually print out. So I'll save and run. Oops. Okay. Oh, sorry. I used 5 instead of percentage. I didn't press shift because the 5 the percentage is on number 5. Okay, also save and run again. Oops, I'm having 1 then percentage. I didn't put a new line here. I'll put a new line and a new tab. So I'll say maybe the modulus or the remainder for x divided by y is, I can put this in caps just to beautify more, not to let them be similar to my variables, but it doesn't matter anything you write, it's the same. It's not case sensitive when you're dealing with printf. So I'll save and run. So the remainder for x divided by y is 1, and this is what I'm really calling about. If you wanted to also bring out this, so I'll say the remainder for, instead of putting x divided by y, I'll say %d divided by %t is %t. So here I'll call out for, I'll first call out for the first %d, which is this. So I'll write that, I'll space it and write x, then I'll put my comma and again space it by y, calling out for the y, then put a comma as well and space, call out the modulus. So this one goes with a respective first value for %d, and y goes in for the respective value for %d in the next line, and then lastly %d integer goes in for this. So when I save here and run, then the remainder for 5 divided by 2 is 1, and that is the modulus. So let me hope we have actually all got to understand that more way better. Okay, so that is with modulus. Then the other thing I talked about is increments and decrements. We shall talk about that when we get to loops. Then when we go to assignment operators, let me give an example of equals. It's an assignment operator, and an example I can give is just like how we declared x equals to 5. X equals to 5, the same as x equals to 5, so that one doesn't change. But we have an assignment operator to say like plus equals. Plus equals, this we write or we use this as an example of x plus equals to 3, and this is the same as the new value of x is given as x plus 3. So this operator is written like this. Instead of you assigning a new value for x, giving it another variable, maybe m or what, you can just write this and then call out this in that new variable. But this is the same as x equals to x plus 3, and meanwhile the same that applies to if we are to write minus equals, this is also given as x minus equals to 3, and this implies that the value of x is x minus 3. That is what it really means. Like, okay, so to give maybe a more illustrated example, I'll say, let me comment this down. Let's say I'm having my integers x equals to 5 and y equals to 2. So if I want to use this argument over here, I'll say that please print for me the value of x plus equals to 3. now close down the bracket like that. So when I save and run, it should give me 8. I didn't put any line. I actually forget that all the time. So put a new line, new tab, or even another tab if I want. Oops. Missing correct here. An error here. Oh, sorry. Before return. Okay, let me try to sketch where that is really coming from. Okay. Put a comma. Close out this. Okay. So I want the value of x plus equals to 3. All right. Something like that. But I'll need a new line, new tab. New line, new tab. Okay. So I'm having 8 up here. So let me explain more about why I have this. So we say that x equals to x plus 3, and remember our initial x, we had x as 5. X initially x was equals to 5, so we get this 5, then we add on 3, and we get the assigned value for x, which is giving us the 8. So that's the argument. Remember, we had 8 we had x equals to 5 initially, so right now we using x plus equals to 3, giving us 8. So that means that the new value of the previous value of x, add on to 3, it should give you the answer is 8, and that's the same. Okay. Let me first clear all this. All right, so let me hope you have actually understood that. And if we are also dealing with sorry, I messed up here. Minus equals the same as x minus equals to 3 is the same as x equals to x minus 3. Okay, something like that. So another assignment operator could be times equals to then this is as x times equals to 3, and it's the same as x equals to, the new value of x is x, the previous one, then times 3, something like that. Okay, and it implies for the rest of the arguments. So if I'm to do with to do with this, if I'm to do with modulus equals, I'm trying to increase this a little. If I'm going to use the and equals, we're actually going to see where we're dealing with this as well. Elsewhere, then if we are going to do with this, or maybe this, so it's likewise the same. It's all the same arguments we use, or the same example we use here is the same that implies to the rest of these. Okay, so that is to do with the assignment operators. Then if we go to comparison operators, that is comparing two different variables at the same time. Okay, so the first variable I want to use is that, and this is meaning that equals operator, and this implies that the data type of the given variable is the same, and it equates to the other data type of the second variable, and it is the same. Sorry about that. Yeah, and it's the same as the first value. So the values should be the same, and even the data type should be the same. So that's what it really means like here. So another comparison operator, it is no equal. We shall have this, we shall have that. This is greater than. This is less than. Then we also have less than or equal to. Then we have greater than or equal to. Then we also have okay, let me first give an example to illustrate this before we go to logic operators. Okay, so the first one equals. So when we are dealing with comparison operators, we are dealing with two variables or two values at the same time. You're not dealing at one value at a time to do with x. We're using two values or more than one value to compare them according to what operator we're actually using. Okay, so let's say an example. Let me use this very example. We're having an integer of x equals to 5 and integer of y equals to 2, and this is where actually I think I should try to also talk about the if statement as well. I'm just going to elaborate more about comparison operators using the if statements and maybe the switch statements as well. So let me try to remove this. Okay, so the first one is this: when we are dealing with maybe let me so comment this. When we're actually dealing with if statements or switch statements, we always need a value that we are arguing about. So let me give an example. If you're writing an if statement, we write if, then we go ahead and put our argument and here. So this is where we put the expression or the comparison or the comparison values here. So let's say if I'm having an integer of x equals to 5 and integer of y equals to 2, I'll say if x is x equals to 2, let me say if x equals to 2, or let me say 5, if x equals to 5, this is where I'll put my print value. So I'll say if x equals to 2, then give me the print value as that's true. That's true. If x equals to 5, let's print this this statement here. That's true. Otherwise, print something else. And that's if it's not 5, print out something else. Else, print out something else. So that's why we write else. Then we put this curly bracket. And we bring out another print value. Shall copy this, not repeat it again. And I'll print out not correct. So if x equals to 5, print out this. Otherwise, let's go ahead and print this. So I'll save and run. That's true. I still forgot to put a new line. Also put a new tab at the end. So it's giving us a print that reads that's true, because I said if x equals to 5, print this, otherwise print this. So it will not give me this statement because x is already 5 up here. But if I say x equals to, if x equals to maybe saying to 2, oh sorry, let me use a different value, 7, print 5, otherwise print this. Let's see what it prints out. It says not correct. Why? Because x is neither 7 but then it actually, the system actually first runs the first code to see whether the argument under the if statement is true. If x is 7, print this, but if it's not this, then rerun the code and print out the second statement. So that's why it's printing not correct. Or let's say if I have 5 here and x I indicate 4, So if I try to run again, it will give us not correct. Why? Because x is not 5, because initially x is 4, but your if statement says if x is 5, then print this. You understand? And this can also imply for in case you're not initially giving in a value, but you're actually requesting a user for the system to actually put in that value for x. So if you give the user access to input the value for x, then you can check is the value put in the same as this or it's not. Otherwise print this, or else print something else. So something like that. So that is to do with the equals. So this checks whether the value and data types are the same as that assigned in the variable that you're actually using within the argument or the comparison section. Else it prints out something else that you print. So that is to do with the equals. Then I'll go ahead and explain for the not equal. Okay, I'll go ahead and explain for the not equal. Let me give an example of let's say I'm having let me just comment this. Okay, let's say I'm still using this. Let's say I have the value of x as 8 and the value for y as maybe say 5. Okay, so and I'm saying this is actually eating up my space. Let me just right up here. Okay, so I'll say that print out Okay, so let me call out here a value. Let's say remember we are dealing with not equal. Okay, so let's give an argument, say okay, I'm going to put in your arguments, sorry, two arguments at the same time. Let's say I'm having x. I'm going to call out for x. X is equals to a. And I'll say this is not equal. Okay. Okay. let me explain why it's giving me a 0. Okay. I say that within x equals to 8, right? And that is true, isn't it? That is true. But if I say that that is not equal, it should give me a 0, because a 0 indicates that something is false, something to do with false. Otherwise, if the value is true, then it should give me a 1. You understand? So I don't know whether they're really trying to get me. Let me try to give maybe another example here. Let me say okay, let me put 4 here. So here it will give me a 1, and a 1 means that this is true. The statement is true because however much x is not 8, but remember I'm restricting this to not equal or to false. Actually, I'm restricting this to false. Okay, that is for not equal. For that, so the argument for, sorry, if I scroll up this, no, I did this again. X equals to 4. So this should give me a return value as false in case this statement was actually false, which is right, because x is not 8. X is not 8, so this should be false. But again, I'm saying that if this is false, if this statement is false, return true. Otherwise, if this statement is correct for x equals to 8, then return false instead. You understand? So that's why when I run x equals to, it's like the reverse of the answer we should get. Because remember when we used if statement that x was equals to 5, remember, let me use 8 here. If x equals to 8, print something, right? Otherwise, if it's not, then print out something else. Maybe that's the same argument that I should actually use. X equals to 8. That is correct, but now I'm restricting the result to give me a false value. Okay, so it will say false. That's why when I run this, it's going to give me a 0, because when we are dealing with machine language, for zeros and 1, 0 means false, and a 1 gives you a true value. Okay, so when I say that x equals to 4 or x equals to 2, which is false, the system will say that, yeah, you're correct because your answer is false. That means you're really true that this is false. So it will say it is a true value, or it's a true argument that x is not equal to 2. Okay, this is not equal to 2, so it will give me true, which is 1. So that is the logic behind. I don't know whether you actually understood me. So if your statement is actually right, the system will give you, okay, you're right. But if it's really wrong and you've said it is wrong, then it will give you that, yeah, you're right, because your answer you're giving for the argument is also wrong, which the system or the interpreter actually gets it wrong as well. So you're right. So that's the argument actually. Then I'll go ahead and try to give another example for greater than. That is very, very obvious. Okay, I'll comment this. Let me just cut it and put it right here. Okay, so I'm going ahead to explain more about this and this. then these as well. So let me pull out my if statement again. Let me say if x is greater, or let me say if x, yeah, let me first use the greater. If x is greater than y, then please print for me this value. Okay, so I'll say printf. If you don't want the new line, new tab, you can as well leave it as you want. Otherwise, you can print out your value the way you really want it to be. I'll say that true, x is greater than y. X is greater than y. Don't forget to close the bracket. Otherwise, if it's not true, please print for me this. And just write false answer. Okay, so if x is greater than y, please print true. True, x is greater than y. Okay, otherwise print this. So if this value is true, then proceed this. Otherwise print this. So that's what the system understands. So if I run my code, it will give me a printout as x is greater than y, because x is 8 and it's greater than 5. Okay, or sometimes if you don't want to use maybe the variables themselves, you can say if x is greater than 2, print this. Otherwise false answer. But remember, initially our x equals to 8, right? And it's not, that's really wrong. X is not greater than 2, so it should give us this. And I tried, right? Why is it giving me x is greater than y? I think I didn't save. Sorry, yeah, sorry, I'm confusing myself. X is really greater than 2. But if I'm saying x is greater than maybe I wanted to say 20. X is greater than 20, which is false. When I run here, it's a false answer. Okay, because x is not greater than 20. Okay, x is 8 and it's not greater than 20. Otherwise, if I say x is greater than 8, which is also wrong, it will be a false answer. That false answer. Okay, because x is not greater than 8. But if you want to make this statement true, that means you can use if x is greater than or equal to 8. This one, greater than or equal to 8. So when I save and run, it should give me x is greater than y. Okay, greater than y, greater than or equal to y. So if I save this, it should give me x is greater than or equal to y. So when I save and run, me x is greater than or equal to y because I've used the argument for x is greater than or equal to a. Okay, so when I try to maybe remove this and say y is less than x. Let me try to reverse. If y is less than x, then give me true. True, it's correct. Else, print for me false answer. So if y is less than x, where y is 5, is 5 less than 8? If it's true, it will give me this. If it's false, it has to give me this. So true, it is correct because 5 is less than 8, and that's what it means. Otherwise, if I would say if y is greater than x, which is false, is y greater than x, then I'll run my value here and say it's a false answer because y is not greater than x. The integer y 5 is not greater than 8, and that's what it means. So let me hope we trying to understand what if statements mean and what some of the comparison operators mean. Yeah, then I'll use maybe another example for comparison operators. You have looked at this, this and this. We did this. I'm very sure you can do this. If let's say if x is less than or equal to 5, right? Less than or equal to 5, print true, it's correct, or else print this. Is x really less than or equal to 5? You give me a false answer because x is not less than or equal to 5. Then if if I say x is just less than 5, oh sorry, let me try to use a more realistic example here. Okay. Maybe let's say x is less than 2. Okay, x is not less than 2 because it's greater than 2. That's really right. If I say x is less than 5, it will give me false answer because x is not less than 5, it's greater than 5 where x is 8. But if I say if x is less than 10, so give me is correct because x is less than 10. All right, So let us not waste much time on this. Let us try to go on something else. So we've looked at this, and this. Okay. There is something else I really wanted to explain more about. When we are dealing with what we call if else statements. So we have looked at this. That if it's given us this, let's say the comparison goes here, and we have said the code blocks go here, or the print values. Or the print values goes here. So that is to do with the if statement. Then if we are dealing with there is what we call if else. So let's say we having more than one argument that let me use this very one. Okay, let's say if x is less than 10, let me use 3. If x is less than 3, print this. Else, so instead of writing else, if I need to make another argument here, I'll say else if, so here I'll call out for another comparison, then I'll put my argument here, another argument, else if x is maybe greater than 10, greater than 3, because remember in the first argument we said x is less than 3, print this, it's true. Otherwise, or else if check the system again, if x is actually greater than 3, then give me another return. Print. So I'll say yeah, x is greater than 3, and here I'll say x is less than 3. So let me hope you're getting me. So for the first comparison, I said if x is less than 3, print out x is less than 3, right? Otherwise, if it's not true, check the system again. Okay, if it's not less than 3, maybe it's greater than 3. If it's greater than 3, print this, okay? Or else, otherwise, if the two arguments are not correct, if these two arguments are not correct, then you can give me something else if I still want to do this. Then I'll say else, give me something else. Copy up this and print out here. So I'll say we say all are false. Okay. So if x is less than 3, print out this. If x is greater than 3, print x is greater than 3. Or if it's not greater than 3, then print out this. Actually, maybe then let me just not use 3 all the time. Let me just try to use another value. If x is less than 3, print this. Then if x is greater than, let me say 7, say x is greater than 7. Otherwise, if this argument does not return correct, then print this. So let me run and see. So x is greater than 7. Why? It skipped. It actually went through the first argument where x is less than 3, and since that x is not less than 3, it skipped this and went to another argument. So it stopped here where x is greater than 7. X is greater than 7 where 8 is greater than 7, which is the x, which is returning a value true, and the true value will give us the print for x is greater than 7, and that's why we're having this print out. Okay, so it never went to the third one because the second one or the middle one was already correct. But when we want to return the third one, that means the system does not meet the first 2 arguments for it to go to the third one. That's why we use else if. So let me say if x is less than 3, print this, which is wrong. So it goes to this. If x is greater than 7, print this. So let me also make this argument false for it to go to the third one. If x is greater than 10, let me say if x is greater than 10, which is wrong because x is not greater than 10, it's less than 10 actually. So it has to give us this. So I'll say x is greater than 10. So when I run, it should say that all are false, like all the arguments are false, right? Because I said if x is less than 3, please print this. Otherwise, check the system again. If x is greater than 10, then print this. But if it's not also correct, please give me something else to print where all are false, and that's why it's giving us this. So if else statement is used where you're having more than one argument at a time, and you want to be checking the system all the time. In case the previous argument is wrong, the system actually goes back to look through where it is correct to give you a correct print or a correct value to give out on the output. Okay, let me hope I'm being really straight. So it's not about using the greater or why. You can use any operator you want here. Say is x equals to 8. It will automatically give us that. Yes, it is. That's is x equals to 8. It has to give us this. It won't actually need to check through the second or the third one. Okay, so when I run, it will just give me yes it is. It doesn't need you to check another argument for the if statement or what. Okay, if I need another if statement here, I'll just erase this and say just giving another else if. Sorry. So you can write as many as you really want in case you need another third argument. Let's say if x is equals to 4, yes it is, else print look or check the system whether x is greater than 10, then print this. Otherwise, if it's not also true, okay, otherwise if it's not also true, check the system again and see whether x or I'll say maybe y maybe y equals to we just use x. You can still use the value of y according to how you want them to be. Or let me say if maybe x equals to, or x is greater, no, x is less than y. So this gives me x is less than y. But if this condition does not meet, then we end with else. Then instead of putting an if statement again, just put else, then print something else. I'll say try again with another value. So let me try to run. Says try again with another value. It's actually pulling out the last print. Why? Because x, when it checked x equals to 4, it is not true, so it went to the second one. X is greater than 10, x is not greater than 10, it went to the third one. Is x less than y? Is 8 less than 5? It's not true, so it will automatically print out the last print. So that's how we use if statements and maybe the likes of else if statements. Okay, so I'll end this video here, and in the next video we're going to look at how to use switch statements. They're more like if statements. You can actually prefer to use what you really want, or what is really much more easier with switch statements and if statements. Okay, thanks for watching, and please don't forget to subscribe.